going to ask Lisa to keep an eye on people for audio such and such. Welcome to, it's been a while, everybody. I mean, we skipped May, so we're trying to resume in June and also a July. So welcome to the Houston.NET user group, the Greater Houston area, in partnership with the North Houston.NET user group. This is number 218. And our agenda, we're going to talk about the agenda. We got some announcements and infos. We got some prizes, which will kind of scale down to the audience size. And then we've got a main event, which actually, funny enough, is me. I'll be talking about AWS and serverless. Some housekeeping. Your wireless, it's the SSA. We changed the name. Now it's called Searching for a Network, just to kind of keep it sneaky. The password is all emojis, so be careful about that. The restrooms are in their usual spot this time, but next month we'll move them. And the refrigerator, it says free snacks, but it's been a rough week, so it's empty. I think all we have is crackers and maybe some old cheese. And not the good kind of old cheese, like the bad kind of old cheese. So sorry. Survey incoming. We're going to be sending out a survey through Meetup, so it'll be a Meetup message with a SurveyMonkey link for us to try to get a feel for what it is that y'all want to get out of GHADNUG, and what sort of topics you're looking for and comfort level of getting back to in person. Just to see where everybody lies. So keep an eye out for that message coming through, and it's going to help us out with planning. It's going to help us out with trying to be more useful to all of you out there. Again, we are part of the .NET Foundation group of meetups. The .NET Foundation is the nonprofit that kind of maintains the .NET organization. If you go to their website, there are presenters, there are open source projects, there are topics, there's learning materials. And if you're more interested in getting involved with .NET, and in terms of doing pull requests or issues or actually working on .NET itself, it's out there in the open. So if you're interested, that's one way to get involved. Other news, we're in our usual locations: Facebook, LinkedIn, Meetup, Twitter. Presentations on YouTube, and the website also has the presentations on there, so you can go check it out and see what we've got. The North Houston.NET user group as well, available through the usual locations and the usual social media channels. Companies hiring, there are these same links I usually post every week, or every month rather. But if you know of companies that are hiring, post them on LinkedIn. Or if you yourself are hiring and you're looking for .NET developers, let us know. We will put job postings and other things on here. Contact us, we'll post it and see who bites. Because the jobs are out there. People are hiring, economy's coming back. .NET's still here. .NET 6 coming out soon. So it's gonna be busy. Prize drawings. We have a very light attendance right now, so I will leave it to Lisa to determine how many prizes we're going to draw, and or what we can do is we can choose to wait a little bit before we do that, but we might as well. Okay, everyone's here. We're here. Let's do it. Maybe we'll just go top 4.
Yeah.
Or top 3. You get to pick. We'll ship some goodies
out. Just a note on that too. We only have a few people. If y'all could just at least send me an email. I know from the last meeting there were a couple of people I couldn't get a hold of. I promise I won't spam you. I'll only send you something if you win. So.
Unless you win spam, in which case.
Can you share your email on the chat so we can message you?
Yes, that would be great. I'll do that.
Okay. All right. So tonight's talk is serverless ASP.NET Core in serverless ASP.NET Core in AWS by me, Garo Yeriazarian. And I will switch gears and present there. So this presentation is a bit of a rehash from one I did for TechFest last year in September, so long ago. And it's a learning from, or it's a result of the things that I've learned since then in AWS and ASP.NET Core and where ASP.NET and .NET has come since then. And I found a kind of a nicer way to implement this and cleaned up a lot of the stuff and made it a little nicer. So I was going to talk through some of the salient bits, but I wanted to start with a bit of an introduction and talk through what it is that I've built in this open source project. And I would like to go into the code, show off some certain points, but I'd like it to be interactive. So if there's an area you're more interested in, go ahead and unmute yourself and ask me about it. Or if you have a question, go ahead and interrupt me and ask me. It's a small group, so we're going to keep this interactive. So if there's something you'd like to see more of, let me know, and I'll dig into it. Otherwise, I've got a few things that are interesting I'd like to show and I talk about, but if I don't get to those and I get to what you want to do, hey, that's winning in my book. A little bit about me. 18 years in the software business. My self-title is Software Whisperer, and it's pretty accurate. I say so myself. I'm manager. I've managed teams. I've done technical leadership, thought leadership, and I like to have a good time. So having fun at work is more fun at work. Houston is where I'm from. Work, school, live, etc. And you can reach me on socials at Garo Yeri. So GitHub, LinkedIn, Twitter. I've got some blogs on my company post there on headspring.com and my personal website, garoyeri.dev. So if you find one of those ways to get in touch with me, then you can get in touch with me that way. Feel free to reach out if you have questions about the presentation or other topics, or just want to say hi. I'm all for that. So, serverless. What is serverless? Serverless is servers. That unfortunate truth is there. And it's funny because when you finally realize that, it's like, oh, it's just serverless. It's just servers. But it's not just servers, it's also containers. So for example, running on a small virtual machine, running container on top of it, running operating system. Serverless computing is really about small compute that you don't have to manage. And you just run your application on top of it. This one, Firecracker, is actually what Lambda, AWS Lambda is based on, as well as AWS Fargate are both based on Firecracker, which is about creating isolation between applications and running your application just on top of a light storage. And we'll show a little bit about how that works now with .NET 5 as well. I want to talk a bit about Lambda. Lambda is AWS's serverless offering. Similar, like, so if you know Azure Functions, this is the AWS version of that called Lambda. And at the simplest level, what's happening is you have a virtual machine that comes up. There's a runtime that executes, and it boots up. So that's called a cold start. And when it boots up, it loads the Lambda runtime itself, which receives the API calls from Lambda, from AWS. And it also fires up your code in a .NET runtime and executes your code as a warm-up. So your startup cycle of your code executes, constructors, start, whatever your beginning. So when Lambda receives a request, it will execute your function within that run, but it does one at a time. And so it runs once, and then it does the next one and the next one. Each of these runs has a max time that it can take. In Lambda's case, it's about roughly 15 minutes. But in terms of, I think Azure function, I want to say it's 300, I think it's 2.5 minutes maybe for the Azure function. So it's a little bit shorter. But the idea is that you do what you need to do and then you complete. And when this function is idle for a certain period of time, it will shut itself down. Now, if you're busy with Lambda and a request comes in, it's going to spin up a second instance and a third instance and a fourth instance. And so you can scale out by increasing the number of instances to serve more requests. And then once you're idling those requests, idling those instances, they'll shut back down. And the idea is that you can scale out as far as you need to. Well, there's a limit, of course, of 1,000 per region in AWS. And in Azure function, it's 200. It's 200 per function, 200 instances per function app in Azure. In Lambda, it's 1,000 total for your account, for your region in your account. So that means that you can have 1,000 things running at exactly one point in time as parallel instances, and then those will idle out and cancel. If you have no room to expand, then it will just queue up the requests and execute them in order. This looks a lot like an ASP.NET Core pipeline, because you have your startup that occurs when you're starting up your ASP.NET application. And then each time you receive a request, a scope is created, you execute that request and you return. And you continue to do that. So one of the really neat things that I'm going to show today, which is the main thing I'm going to show today, is how you can run ASP.NET Core inside of this Lambda infrastructure, and show a little bit about how that looks and talk a bit about why we would do that. I'd like to start with how that looks in terms of an architecture diagram. So the project I'm going to show you today is a relatively straightforward diagram or architecture in AWS. It's all in one region, keep it simple. There's two starting points, two endpoints. There's an API endpoint and there's a website endpoint. And then I'm using Auth0 for authentication. This was super easy to use, so I really like it. And so when the request comes into the website, we're using CloudFront to host the SSL termination, and then the actual single page application in React is hosted on S3. And then there's a little thing on the edge that adds some secure headers to the application, which is useful. We have our domain name subdomain structures hosted for Route 53, which is the DNS structure for AWS. And then we also have the API gateway for running the API side of things, which I'll talk a bit about too. There's also an authorizer bit in the middle that makes it so that unauthorized requests don't go to our ASP.NET Core application. And that helps reduce a lot of the wear and tear of that. For the database, we're using DynamoDB, which is Amazon's NoSQL offering. And it's got a reasonably simple structure that we set up. And then we're using CloudWatch for logging to log the individual requests going through. And we'll use Insights to do a little bit of looking at that as well. On the deployment side, coming in from the far right, we're using CDK, which is AWS's infrastructure as code offering that creates CloudFormation stack. And CloudFormation is AWS's native deployment technology. This lets you use TypeScript to create deployments, and I'll show you what that looks like as well. So the idea is to go through a lot of different points of this architecture, show you what's interesting in the code, show you how AWS supports it, and especially in the .NET space, and then answer any questions, do any demos, look at any details, and really get into it. But the main key point I want to talk about today is that ASP.NET Core can run as is on a Lambda architecture. And the main benefit of it is that you can scale out to as much as you need to support requests, but you can also scale back in to 0, and the whole application can go idle when you're not using it. And so without you actually needing to customize that. And that's the number one benefit of the Lambda, is that you can scale out and in automatically. And you can deploy it into other infrastructures and regions, and it will scale in and out as it needs to. Any questions so far? Anything that you'd like me to talk a little bit more about while I'm looking at the architecture diagram? Okay.
What you're talking about, like the front end over here, S3 front end, like cloud front end. So is that, in what way is that the front end? I'm thinking more like not like a regular UI like React kind of thing, right? Or is this a service?
It is a React single page application.
Oh, okay.
And so since it's a static web application, we can host the code is hosted on S3, and then we use CloudFront to distribute it on the content distribution network. In AWS, this is a common pattern because S3 on its own can't use custom domains, and you can't use SSL to get the file. So CloudFront is needed to give you the SSL termination, which gets you HTTPS, and also it'll distribute the application to the region edges, which gives you a little better access to your static assets.
Okay, so this is for the whole application, not just the Lambda.
It's only for the front end of the application, so just the web interface.
Oh, okay.
So the Lambda is still here. It's separate. So we've got two endpoints, right? What happens is if I go to the website, it's going to go to CloudFront, and CloudFront is going to serve up the static content. If I hit the API, it's going to go to the API gateway, and it's going to activate the Lambda and serve up the dynamic content. And so the front-end application has a REST API call that talks to the gateway and sends a request out to the API gateway.
Okay.
So what'll happen here is on the browser, on the users, they'll go to this website, then it'll go to their browser, and then that browser will contact the API to get the what's going on down here. Did that answer your question?
Yeah.
Cool. I'll show you a little bit about how that works and what it looks like on a deployment side too, so we can get into that. Nobody. Okay. All right. Let's get into demo time. So I want to make this a little nicer looking. So let's close this tab and so I wanted to show the site first. Let's pop this guy open. It's front end is not my forte, so I'm just going to say that the website is kind of gross looking. What we've got is a simple website called Laughing Grown, and it's my sense of humor is terrible, and so I like to have a place where I can post links that make me laugh or make me groan. So it's either or it's like, yeah. When I log in, it goes to Auth0, and I get a custom login screen. I can have a custom account login, or I can actually use my Google account to log in as well. So I can sign in with Google, do a social login, and now it's got my information. What I had it do is this is my username. It's randomly generated, and we've got some posts that were created last time I presented this topic. So those are still there, and some new ones too. So I can put in another thing. We'll call it last name. Say GitHub, and then I could say we're going to go to github.com. I'm pretty sure this is the right URL. And we'll post a link. link is posted successfully, and I forget if it actually refreshes periodically. It might, or it might not. So I'll go ahead and reload it. Like I said, front end is not my specialty. But so here's a new thing that shows up. There's got a link, and it goes in. So what's happening behind the scenes is just a simple, uncomplicated ASP.NET application. So if I have title and link, needs to be URL. What I'll see is that there's a post that's done. Let's see if I can make, usually this part doesn't go bigger, does it? Okay.
But you can hit escape and it hides the console.
Okay. All right. So what we're seeing is that there's a call, there's a post to posts, and it's a post, and it's going to send the contents, the title, and the website that I had just sent. So it's just a regular API call. And this is going to api.laughingprone.com/posts. Now, if I wanted to actually see what the API looks like as a surface, I can go to the Swagger page. And, oh, buddy, tell me that's not going to work, huh? Of course it's not going to work. It was working literally like a little bit ago. Oh, because I'm sending. Why am I sending?
I'm not sending
It should be unauthenticated. This part is. Oh no, never mind. This is correct because I turned it off. That is correct. Okay. I have it locally. The Swagger page is local because the Swagger takes a bit of time to start, and so I actually turned it off on the Lambda side of things. So that is expected behavior, and I'll show you. So this is roughly what the website looks like. There's not much to it. Now, if I wanted to see what this looks like from a code perspective, so if I'm doing an ASP.NET Core application, then this is my program.cs. This is my entry point. So I have my main. I'll set up my logger, and I will start the web host, and I will create the host builder, create a default builder, web host defaults, use startup. These are all part of the basic template. This is ASP.NET Core, and my application will start. However, if I am going into a Lambda, and I can go back into, so with the Lambda, then I actually have an entry point that's a Lambda entry point, and there's a base class here that's based on the Amazon provided library. And what this does is it provides the program CS startup to set up the host and set up the startup and initialize the ASP.NET Core pipeline, similar to the way that a application does. Except in this case, it's actually going to run the Lambda runtime instead. And it will construct enough of a web interface to be able to run requests. So the difference is that in the local entry point, ASP.NET Core will use Kestrel to run the web request, to do the HTTP server. In Lambda, it will actually intercept the Lambda, API calls and extract the HTTP information from that and run it through the ASP.NET Core pipeline, ASP.NET Core pipeline. So that means that your ASP.NET Core application works the same way. Routing, model binding, you can do Razor pages, you can do everything that you can do, in an ASP.NET Core application, but one request at a time in a Lambda interface. So that there's a few different options here. There's you can actually do a load balancer input directly from the load balancer and receive WebSocket type requests, or you can go to the HTTP API and receive HTTP payloads. Or you can use the old REST API, this is API Gateway v1, which is another AWS product. I like the v2. This is the easiest way to go, and that's what I've been using here. So this is API Gateway HTTP API v2 proxy function. There's some documentation around this on the open source project as well that will show you a little more about how this works, what it does, and you can go in the code, and it's really fascinating how that functions. There is a template, and I wrote a blog post about this on my website as well. So if you're interested in just the bare minimum of how this works, then I've got a link for you. So for the C# advent of code, I wrote a quick rundown, not a runtime, of how this works from the template, and what's the basic solution, and how do you actually run it from the ground up. So using the templates and setting up the template and deploying it all to your AWS account. So this is another way you can look at it if you want something a little smaller. This would be a good way to start. All right. So I want to show that this runs locally, the same as a regular application. So let's go into our terminal, and I'm going to, so what I have is so DynamoDB is Amazon's database, but I need to run it locally. So I actually have it running as a container image locally. And let's local DynamoDB. It might already be started, but just in case, sometimes I forget, so I like to start it. Okay, so now I have it running.
So do you have to run it inside a container, or can it be without a container, just in case like your application is not going to be really scalable? You don't need to make it that much.
So this is for testing locally.
Okay.
What if you don't want to run the container? It's the Dynamo has a local database option that runs as a Java. It's a Java application. So you need to make sure you have a Java something installed, and you have the thing set up. What I found is that in Visual Studio, there is a AWS. Let's find it. There is a way to run the DynamoDB from AWS, or sorry, from Visual Studio locally as well. So what you can do is you can go to DynamoDB, and I can change this to local, and then it will actually, I can set up a Dynamo and run it if I wanted to. Right now I'm running the container one, so actually I can just connect to it. So this one actually lets me set up and run a custom one. I don't have Java on here, so it doesn't actually run it from here, but it's running already, so it'll work.
Okay, so you are doing it so that you can emulate the Amazon environment, AWS environment. Is that
correct? Correct. Yeah. Exactly. So I can run all my tests locally. So what my unit tests require is Dynamo running locally, and I can connect to the local instance, run all my tests, and I'm done. The way that looks is I have a find it. I have a Docker composition file, and this will set up the DynamoDB local. It's all in Docker, so you just get the image and then set up a container name. This is the startup stuff, and we'll just have a local volume. So it actually will store. It'll create a file here to store the local Dynamo data. So if your container gets destroyed and comes back, then you've got the file still stored locally that it can use to bring the data back. Similarly, you can blast the data and start over. So if you want to do a clean database each time you do a build, or have a different database for running tests versus running the application, then you can juggle that a bit by using different data pointing to different places. And so you can fire one up or the other. You can also listen to different ports. So as long as it's you're overriding the URL, you could say my Dynamo's local, and it will connect to the local one instead. The thing that it seems like it's missing though is that Visual Studio actually has a little client to work with Dynamo, but looks like it doesn't like to connect to one that it didn't create on its own. Oh, actually, no, here. I can do this, and I can do, no, it still wants Java. Do I have Java installed? I don't think I do have. I think I took it out. So if you install Java, then you can connect to the Dynamo client as well and look at the structure of the database. Maybe I'll do that for next time. So this is great to run things locally, so I can run my tests. So if I did, then I can run my unit test locally, and it'll execute actual database calls for the unit test. So they're really more like integration tests. That's one of the things I like to do is when I'm testing, I like to just put the whole system together and test. Similarly, when we actually run the tests, we're going to fire up the entire runtime or the host. So when we start, we're going to configure a web host. So this is new in .NET 5. This, I think it's new in .NET 5, Web Application Factory. So this lets you actually create a test startup using your startup class, and it will create enough infrastructure to run things, and it lets me run my unit tests. And then all I need to do is add the extra configuration here to tell it to go to local DynamoDB for accessing Dynamo. So when I'm running my application for my actual test, I'll go into the factory and I'll get the scope factory and I'll create a scope and I'll create services that I need to test and I'll execute against those actual services. This makes it really easier to test the whole thing because I can run the actual application and the actual integration code and the actual services and make sure that everything's working together. So that's super helpful. But still running just building all the JavaScript stuff. Now finally executing a test.
That as always takes forever.
Yeah, the JavaScript stuff does. If I don't do the JavaScript stuff, then it's a quick test. Because when I'm running my build script, it was building all my JavaScript items. But if I just run the unit test, I'll show you it's pretty quick once this is done. Okay. So the actual test didn't take long to run. So if I wanted to run my tests, I could execute them from here. Go. So it's just going to create the structure once. So the thing is, I create this once. I don't create it more than once. So it's going to create the whole application once, and then it's going to run all the tests. So the startup time takes a little bit of time, but once we're ready, it'll go pretty quick. But if I'm running a ton more tests, usually more of the time is spent running all the tests, less of the time is spent starting up. Starting the API. So while that's running, start the API. So the API is a .NET Core application. It's a normal startup, as you can tell here. Looks like an ASP.NET Core, and we're actually running it on localhost. We'll go to localhost. Which browser did that pop up? So we'll go to the Swagger page, which I promise you is there. And this is the API for the application. So this is actually generated using a library called Swashbuckle. Swashbuckle is looking at my controllers in ASP.NET Core, and it's generating, based on the attributes, a Swagger file, which is our API specification. So one of the neat things that I added here was, since I'm tied into Auth0 for authentication, I can just click authorize here. So right now, if I try to execute an API, bad things will happen because I'm unauthorized. But if I click authorize here, I can say, let me log in. It's going to use the same login system that the application uses, And now I can actually execute the API request, and it passes the token I need and will execute the response. So now I can do my testing of my API from the browser. And I don't have to remember, I don't have to have an endpoint for login. I don't need to remember my access token or anything like that. I'll just click authorize and I'll log in normally. And then I can look at my data and see what's going on. This is one of the benefits of going to an external authentication system that has the OpenID OAuth style authentication. So highly recommend. Auth0 is great. I like it because it's really simple and easy to get set up. So they have a lot of great documentation, and it was really simple to get running. So they have a lot of kind of like, let's walk you through this, and you tell me what you're doing, and I'll figure it out for you. The free tier is up to 7,000 users, and you can connect to one social login with that free tier. So I've got mine connected to Google. If you pay, it's actually not terrible. Let's see. Yeah, $23 a month. If you want to do more, so you can do 10,000, more social connections, custom domains, user roles, and then some hooks and actions and stuff. So if you're doing authentication, that's probably a really easy way to go as well. Highly recommend these guys. I don't have any stake in them, and there's no no kickbacks or anything like that for this, but I like it genuinely as a product. So that was my fun stuff. Swagger, great, easy to get into, and gives you some more documentation on the different parts here as well. So this is great for testing out the API without a front end. Now, but let's say I want my front end, then I want to run that as well. So I'll pop a new prompt open. And okay, my unit test passed. Great. So funny is because the unit tests are there, it actually creates a bunch of posts, and I'm looking at the same database. So you'll actually see the things I use for the unit test will show up in the database. So it actually logged in automatically because I was logged in on the other window, and so it went ahead and used the same account. So this is me on the website, and I think this is logged in. Oh, it's a different database, so the name's gonna be different, but the login is gonna be my credentials, so it's gonna be that one. And same thing here, but I created a new name for me. Is it a different name? It's a different name. But there's a lot of test ones here that are created for samples. So it's gonna eventually going to load up the database with a lot of good stuff. So here is the front end running. And just to prove that it's going and it's connecting locally, I'll go to the network tab, reload the page, and we'll see that the post request is going to localhost. So it's actually connecting to the other instance that I have running. So that I can test the whole stack locally. I'm not running anything Lambda, but I'm running Dynamo. But I can run my SPNet core application, I can debug it, I can test it, I can do whatever I want to do to develop it. And my development workflow is exactly the same as it was already with ASP.NET Core, except now I have the option to deploy it either as a whole container to ECS, or deploy to Azure App Service, or deploy to AWS as a container. Or I can take that same code, repackage it as a Lambda, and host it as a Lambda as well, which gives me a flexibility. So the same .NET code will execute in all these environments, in Windows and Linux, in container, Docker, and in Lambda. And I don't have to do too much special to make it work. Questions so far?
My question was earlier from what we saw earlier, right?
Okay.
Using AWS versus using Fargate, at what point do we start using too much Lambda or the traffic is too much that it makes sense to have something running 24/7, right?
Right. So the challenge of Lambda, and I'll refer back to my my presentation here because there's a really good get to that diagram real quick. This one. Okay, so this is where things get weird with Lambda. You only execute one at a time. There is no background with Lambda. So when this request is complete and when you're idle and there's no Lambda API call executing, everything else is frozen. Your application is completely frozen and waiting for the next call to come in. And then it unfreezes it and continues execution. So if you need background jobs within the container, or if you need other asynchronous processing that happens after the HTTP response comes through, Lambda will not work for you. So if you've got if you're using Hangfire to run some jobs in the background, this is not going to work. But maybe that's not the best way to do it anyway. In a serverless infrastructure, in a cloud environment, those background jobs really need to be other Lambdas or other tasks that execute that you can spin off separately so that they don't use up your compute time of your main request processing. So your application can be designed to handle those alternatives and to work in a more cloud native way. Or you can bring it all back together, run in a container, and have it running all the time. What I found was there's definitely the behavior of the Lambda. If you have a lot of requests happening and it's always active, then Lambda will perform better. Because if you have a lot of like idleness and coming back and idleness and coming back, then that cold start is going to hurt you. Every time that new instance comes up, you're doing this warm-up time. That's going to eat into your responsiveness. So I like the idea of Lambda as let's try this first and see how well it works. And if it does the job, then it's a lighter weight deployment that can go down to 0. But if I have harder requirements of responsiveness, and if I have if I'm dealing with requests that can take longer than 60 seconds, then I need to use the container, because Lambda is going to have a timeout for the request, and it's going to want you to execute things quickly to take better advantage of it. So if your requests are going to be small, simple requests that execute quickly and are returning, Lambda is going to work really well. If your requests are more longer lived and heavier consumption of memory and CPU, the container is going to serve you better, because then you can do your own, get your own compute allocated for it instead of using Fargate, like actually allocate EC2 cluster or use Kubernetes or use some other technique that's going to give you that dedicated compute at the level you want. But most of the time you don't need that. Most of the time the request is coming in, you're transforming it, you're going to the database, doing something, and you're returning a response. Or you're kicking off something else that happens through a queue, and then that just executes, and you're done. So the Lambda is really great because you're just taking something, passing it off, and returning. So I will say it depends, but there's definitely some characteristics. But until you try it and test it, you're not going to know what works best for your situation. So it's great to have this as an option where you can scale up and down without needing to mess with containers, and you can pay only for what you use instead of having to pay for the container running all the time.
But there reaches a point that saving of pay for what you use overpasses the cost of having the container there 24/7.
That is correct. So if you end up hitting a spike of usage, then Lambda is going to cost you for that usage. So it's less predictable on the compute. But you can set a max on it that says only go to this much. So you can cap it if you need to. But ideally, you're not going to. You're going to let it run and say, well, I need to serve the requests, so I'm going to serve the requests, and I'm going to pay for what it is. So if you want predictability in billing, containers are going to give you that flat rate. If you want flexibility and scaling in and out, then the Lambda is going to give you more of that kind of real-time usage.
Yeah, the part I like about the Lambda, it's the whole coming up from queues, just a queue message or reacting, listening to just an SQS message or a timer. I think there's a way to do things with timers as well, for it kicks only at schedule intervals.
Correct. Correct.
So
Yeah.
let me ask you something that I usually do, right, on my own pipe, right? For what I work right now, we have everything still on-prem, right?
Okay.
But on our own .NET Core pipe, what I have is before, after authentication, and before MVC, I log the request, right?
Okay.
Give it to the next level of the pipe so MVC can do whatever it wants to. Then I log the response, but I log it asynchronously, so I don't delay the response to the customer.
Right.
Right? Lambda would not work for that because there's a background that still runs after, correct?
Correct. Now,
okay.
What you can do with Lambda is, if you're using CloudWatch or if you're using X-Ray, the AWS services, then Lambda has a way to, you're sending the message out to those, but you're still going to incur the cost of serialization to take that log entry and convert it into structured JSON or whatever it is, and then send it to some other service. So that has to completely execute before you return.
Okay.
So yeah, you're exactly right. If you're needing to hit a tighter performance on each individual request, and you do want to log a lot of things, and you want to have that kind of asynchronous process afterwards, you're going to want to do that. You're going to use a container for sure.
Awesome. Yeah, that helps.
All right. So what I was showing was web applications running locally, and web was started locally. We went through the links and so on. I want to talk a bit about deployment, because deployment is interesting. And so deployment here, so .NET 5 on Lambda uses Docker. So before what was going on with Lambda was that you had to use the runtime. Oh, so there's two ways to do it. You would use the runtime provided by Lambda, and they were tracking the LTS versions of .NET, so 2.1 and 3.1. Version 5 comes out, and they said, well, we're not going to support 5 natively because it's not an LTS version. Excuse me, 6 is the LTS version coming out this November. So instead, AWS said, well, Lambda's containers, so instead of having Lambda in layers as it is now, why don't we let you just create a Docker image based from our Lambda Docker images, and go ahead and load your code into it, and we'll execute your container image. Instead of having to build a custom Lambda deployment, you'll just use your normal containers deployment as well. So this lambda.net image is it has the Lambda runtime, an entry point script that will fire up the Lambda runtime, fire up your code, and then tell Lambda that this is the entry point for your code, which is the Lambda entry point we were looking at before. It will compile it locally for Linux because the Lambda runtime is Linux x64. So it will compile a .NET 5 Linux x64 publish when it runs the build. And then it will create the container image. So if I look in my local image list, I'll see that I have the API that I just rebuilt. So there wasn't much change. So it actually it didn't really change the tag of it. But here's one I built last night. So this is the image, and I can inspect it. So if I go to Docker I can go to the images. I can go into this one, and I can. Oh, sorry, that's the. So I've got my command, which is running my thing, and then it's got all the different build steps. So this is just giving us the steps of the image. It doesn't give me the other information. Oh, because it's just an image, so it's going to give me. But I can take that and run it locally. Can I run it locally? I haven't tried that actually. I know that there's actually a Lambda Docker you can run locally if you wanted to, but it's just kind of more complicated to run this locally, and it's not really helpful because if I'm testing locally, I'm going to test the ASP.NET Core on its own, running ASP.NET Core locally. So this is more about how the container is created for Lambda to consume. So the container image is created and uploaded to Amazon's container registry, and then the Lambda that's created will point to that container registry to pull the image down to execute. The deployment I'm doing is using a technology called CDK, and CDK, and I'll just kind of do a quick pop-up here on that. CDK is primarily a TypeScript-based look at this one. Yeah. Okay. So CDK is a primarily TypeScript-based system for declaratively defining your resources that you want in Amazon, which is the same as CloudFormation. But what's nice about CDK is that it provides a lot of helper methods that let you think about permissions and relationships between services, and it will create the IAM policies in between and the permissions in between, and you just tell it, this service needs to have access to this service. So you go ahead and make that happen for me. And it will automatically create the security policies around what it needs to do to connect those two. So if you've done deployments in Amazon, you know that creating these IAM policies is the most obnoxious part of it, but also very useful because it's telling you, you know exactly what's going into it, but you have to know that, okay, these are the API calls I want to make from my client, and the server needs to accept which client is going to call it and access it. So both sides have to agree. And so you'll have to create permissions on the server side, on the service you're calling, and you have to create role policies on the caller side that's calling the code. And CDK will let you make those, connect those dots automatically. The easiest way to explain that is when we look at how we connect the Lambda to the database. And I want to say I do that here. It's going to be in the database, then I'm going to do the Lambdas. Okay, so what I'll do is I will take, now I only have one Lambda. I used to have 6 Lambdas, but now it's down to 1 Lambda. So I'll just do this. So given my Lambda coming in here, and I can, since it's just one, I can actually probably just do no problem here. So I'll say, and then I'll say grants. So I can do different things. I can grant full access. I can grant read, write data, stream, and so on. So I can actually pick which permissions I want to give, and it will create the policies in between. And so if I want to just have read only, I can say, okay, grant read only access to my Lambda here. And so when this executes, it's going to create the policies I need around it, which is super nice and super helpful. So if you've messed with the deployments in AWS, this is way easier. Also, creating the Lambda from an image. What I've done here is I've created the Docker image function, which is a Lambda using a Docker image. I've told it to go to my application folder, which has a Docker file in it, And so this will, CDK will automatically create the container and it will publish it into a repository and then reference it when it's creating the Lambda during deployment time. So that's been super nice as well. The Lambda itself, that was the Lambda itself. So the only things that are usually, so the only API I need to call from for AWS is going to be the Dynamo. So I'll put that here. So I'll pass in the Dynamo tables from the previous call, and I'll add them so that I'll grant access to them. So each asset you create, like if I create the database here, I can return them as TypeScript objects and then use them in another part of the application. So if I go to my stacks, this is where it all pulls together. Then I'm going to find out where this. So I'll say create my database, and my database is going to return an object that has some goodies in it. I'm going to create my lambdas. I'm going to pass the two tables from the database into it so that it can grant access to it. I'll create my front end, and this needs the domain name and it needs a certificate that I've got on my account. And then I'll create the API gateway, which glues everything together. So I need my domain name, my certificate, my lambdas, some parameters that are passed in, like the auth client ID and the auth issuer, and then where I'm hosting it in my hosted zone. And so this will create a complete CloudFormation file. If I want to see what that looks like, then I will go to Y, and I'll do do I need any other things? No, let's do it. So this will take my script files and generate CloudFormation, which is what it will execute when I want on the server or in the cloud. Now it's complaining because I need to set. How would you complain about that? Need to. Oh, I need to pass my profile. That's right. I have to go through my history to see what I actually executed on the command line. This is why I do it through the build script, because that way I don't have to remember everything. The build script has all the notes of what I'm running. So what this generated is a bunch of YAML code, which is my CloudFormation script that's going to execute. I don't want to do this because this is, I've done big CloudFormation deployments and they are terrible and they're gross and they're unfun. So it's great that this generates it. So what I can do is I can say, okay, well, what's different between this and my Amazon account? So whatever I have locally, did I change something? What's different? So I can run a diff and it's going to calculate what's on the cloud and what's in my local scripts. And it's going to tell me what's going to change. Well, it's going to give me a guess and say, here's what's probably going to change. Now, because it's a scripted environment, there's this weird stuff where there's some metadata that's getting added to things. And honestly, it's just, it may change something, it may not, or just may kind of tweak some parameters. So it's nothing really crazy. I don't want to say anything else because I didn't change anything. But if I wanted to change something, then I could redeploy the application, which we'll actually do, or I could say there's nothing inconsequential to change where I'd want to do it. Let's say I wanted to, hypothetically, let's shrink this. Go to 512. I don't need that much memory. So I'm going to change the size of the memory of the Lambda. I'm going to save that. But then I'm going to, go in here. I'm going to compile the deployment code, and I'm going to do a diff, and I'm going to see what's changed. All right, and then execute a diff. And so what this is going to do is it's going to take my plan, and it's going to compare it against what's in the cloud, and it's going to tell me what changed. So I should see that weird little metadata change, and then I should see that it's changing the memory size here. So it's changing the memory size from 124 to 512. So let's say that's what I want to do, and I want to deploy this. So I'll go ahead and just, I'm not recompiling any code, so I'm just going to go ahead and run. Should I do a full deployment? I'll do the full. We'll do the full Monty, just to be sure. So I have a build script that takes care of this, and we'll review that real quick. And so what it's going to do when I run deploy, it's going to run publish, and then it's going to deploy it. So it's going to recompile the code, and it's going to deploy whatever I need to deploy. So I will do no. Oh, okay. There we go. Okay. So let's do a deploy. And so this is my, let's build everything and deploy everything. And so it's going to go and it's going to compile. It's going to create the packages. It's going to move some stuff around. It's going to change the way that the web application points to the backend. And it's going to go to there. But one of the cool things that's part of this deployment is the front end. So we talked a bit about, there was some questions before about the front end. And there, with this code-based deployment, there's an opportunity to look at things that are provided by other people that have already made a template. That's nice. And so in this case, we're using this template from Cloud Components called CDK Static Website. And what happens with this is that you give it some parameters, and it will create all the resources you want for you. So if I'm looking over here, Cloud Components, go to the GitHub link. And so they've got a bunch of cool stuff in here. So they've got one CDK Static Website. And CDK Static Website will do a static website using S3, CloudFront, and actually route a custom domain to it as well. There's some other stuff too that, like, if you want to follow these patterns, so if you have a CDK dependency check, or if you're doing chat ops, or if you have some other stuff, they've got some like pre-built things that are nice to have. But I like the static website because I've done this a few times, and they keep it up to date, which is great. And so what you do is you take their code and you call it their constructs like static website and headers, and you create the necessary bits for it. You pass the parameters you want, and it will deploy your application. It will set up the S3 bucket with the right permissions. It'll set up the CloudFront with the right permissions, and the secure headers as well. So that's been super nice. So in my code side, what that looks like is I set up the headers I want, and then I set up the website I want. Because this is a React application, then the index and the error document need to be the same, and React routing takes care of the rest. And then I want to make sure that I destroy this if the resource is destroyed, I need to make sure that I destroy the resource as well, because normally buckets will stay around because normally you don't want to delete what's in them, but we want to make sure it gets deleted, so we'll mark it as destroy. And it will also reference our certificate and our security policy and what we want to set up for that. And so this will create all the resources we want for that. See if our deployment succeeded. It failed because of that same reason, because I need to set an environment variable. So there are some AWS environment variables we need to set. This one is picking my profile for AWS, which connects to my account that I set up. So if I don't do that, then bad things will happen. So because I got most of the way through, I'm just going to go ahead and just skip to the deployment part. Deploy. Deploy. Now that I have the environment variable set, I can just do this. And so this will take the compiled result and should run the, so because I didn't do require approval never, it's going to ask me about any changes to IAM policies, but I don't think there are any, so it should actually be pretty straightforward. So it will upload any sort of binary bits that it needs to upload into S3, and it will create the container image. It will push the container image very carefully. And it will deploy the rest of the stuff. So this is something you can run in automation, in continuous deployment. I'm running it locally just because it's convenient, but I could actually move it into a GitHub action and have it deploy on a merge to master. And so making sure that the site's always up to date, or tag a particular revision and say when I see the new tag, then trigger a GitHub action to go and deploy the stuff. And then so because what I need to run this is really just Node.js and Docker. So as long as I can do those two things, then I should be able to run CDK to do deployments in any environment. We'll let that run. So while that's going, I will show you the AWS. So this is my AWS account that's set up. Let me see how the deployment's going. Let's do this thing. Let's zoom a little bit in. So API gateway, this is what actually is the API. The routes, I need to reload the page. Oh, buddy. Make me work for it, aren't you? It's going to make me log back in. All right, let me do this off screen. Gotcha. Password 2345. My fake code. Security, security, security. I was being clever by leaving it logged in, but what I found was that it it logged me out anyway for inactivity. So clever, but not that clever. Okay. All right, buddy, welcome back. So what I can see here is the routes that I set up in the CDK are set up in the API gateway. If I look at this, this proxy means just catch everything. I had set up a route in case I deploy Swagger. I want to have Swagger set up, but I want to make sure that Swagger does not. I want to make sure that Swagger does not require authentication to execute to look at the Swagger page. But the rest of this requires it. So I'll look here. There's an integration which talks to Lambda, and it just says, okay, I'm going to talk to Lambda here. And then there is a authorizer tied into these. So it says if I'm using any of these requests, there's a JWT authorization, and I pass the parameters. So I know that the issuer should be this auth0, and the audience should be this API. So I can also add scopes too if I wanted to enforce scopes. Then what happens with the benefit, the real benefit of this is that if the authorization fails, then my Lambda code is not executed, and the authorizer will just reject the request altogether. So I don't have to process unauthenticated requests. I will only process requests that matter to me. And that's a promise. Cores, I turned off the cores from API Gateway. This is always terrible. It is gross and it doesn't work all the time, and it's I hate it. I hate it a lot.
So I'm not the only one that hate cores completely.
Yeah, everyone does. No one likes cores, but it has to be done. So instead, I'll use the one in Visual Studio, or I'll use the one in ASP.NET, and I will set it up in a very loose way.
I'll allow everything.
Yeah. So there are headers that we need to allow, though, and this is related to AWS. So there are some headers that we need to make sure we allow and filter. So this is a good one to do. And in methods, these are the methods I want to use. I'll allow any origin. And then this is a nice one too, set a pre-flight max age. So it says, okay, check it once an hour. You don't need to check it all the time. So just let them know, like, if you check it once an hour, we're cool. Don't worry about it. This is not a bank. This is not a stock system. This is not your medical records. This is a joke site on the internet. So this is not terrible. But if you're running a more secure system, then you'd probably want to be a little more careful with it. All right. Then, oh, it's here. All right, course. The lambdas themselves are the lambda themselves. There's a lot of leftover bits here, but the one that matters is this stack right here. And actually, because, like I said, since this is running CloudFormation, it may be easier to look at it as an application. So I have Laughing Grown Stack. So I can look at all the things related to the stack, and it's going to show me what's there. So there's a bunch of resources that is tied to API Gateway and the Lambdas and other bits. So it's a little easier to look at it this way to see what's everything that's tied to this application. We'll go to the Lambda. So with Lambda, we see that the input's coming from API Gateway. To execute, there's no destination, there's no output. So there's no outbound permission that we need from this guy. If I look at my configuration, image URI, so this is going to the ECR, the repository where the container is. And then I can look at the permissions, once more here, and see what I'm allowed to do. So I'm allowed to call Dynamo, and here's my tables, and I'm allowed to do stuff with those tables. So this is me seeing that my permissions are all configured the way I expect them to be. The testing, you could in theory test your Lambda here. I'm not a fan, honestly. Also, what you'll find is that in these templates, there is a Amazon API Gateway AWS proxy, but you'll find that it's actually the wrong one, and it will not work because this is the old template, not the new template. So it's not going to be helpful to use this. So I don't recommend you do it for this case. For testing simpler Lambdas, it's probably good, but for the case of this AWS Gateway, it's not. It's no good. So don't worry about it. We can also go to monitoring, and we can see the execution of our Lambdas. And CloudWatch is the service we're using to review logs. We can also look at just the regular usage of this. So we can see how much memory we use. So in this case, we only used 120 meg of memory because it's only executing one request at a time, even though we've allocated 1,024. So we just sent the reconfiguration to try to shrink this. Did it shrink it yet? No, it has not deployed yet. I think it's still hanging. There we go. The deployment's ongoing now. So it started the CloudFormation deployment, and it's going to slowly execute that. I don't have to watch it because it's actually, everything has been uploaded to AWS. And so whatever I see here is just status. The actual deployment is occurring right now in the cloud. So if I did go to CloudFormation here, then very carefully, very deliberately, I could see there's an update in progress. So it's actually doing events here. So whatever I see here on the events, this is the same thing I'm going to see here on the console as it's executing. So it's great. It's really easy. This has been really helpful. I find that CDK has been super helpful for when I know I'm in one region at a time, and I know that I'm working only in AWS, and I know that the team I'm working with maybe is not quite as advanced in cloud deployment, then I would probably opt for CDK for AWS. However, I do have a preference for Terraform, because I feel that Terraform gives you, while it doesn't give you the deep integration into AWS that CloudFormation does, it is better at doing continuous deployment, of figuring out what is the current state of the cloud, what does it need to be, and how do I connect the dots between them. Because if you try to if you change the configuration manually in CloudFormation, it will not know what to do with it. And you could get the stack into a bad state where you have to tear the whole thing down, which is terrible and bad. So I do recommend that if you have a team that is more advanced in their deployment and they want to take the time to learn new technology, then Terraform is going to be a great bit for you. But if you just need something smaller, then CDK is great. It works really well. The tooling is pretty good. It's got some quirks to it, but for the most part, it will do what you expect it to. Any questions about the AWS, or if there's something specifically you'd like me to go in and show while I'm hanging out in here? Otherwise, I'm just going to prove to you that it's uploaded and it changed the memory to 512. Hey, the cloud is updated. It's great.
It works.
Yeah, right. It's a demo. It's a demo, and it works. This is great. What I do like about, so one thing I'll say more about CDK. When you're trying to figure out how to deploy something into the cloud, I really like the way that this is structured, because half the challenge is figuring out, okay, I have these two pieces. What are the resources I have to create in between to make them connect and talk to each other? And if you're not familiar with this if you're not familiar with AWS like deeply, then you may not know exactly, well, how do I connect the dots? And that's where this is super helpful, because I can look at an example and say, hey, I need to do a gateway, an API gateway. And okay, all right, API gateway. And I can look at the example and it's like, all right, well, you're gonna do a okay, HTTP API. What's the minimum you gotta do? And we'll say, okay, well, this is it. This is the minimum. You'll create an integration, and then you'll get your Lambda function created, and you'll create a proxy integration. And then you'll just add them to routes, and it's there. And if you want to do more, you do more. And so it will figure out, okay, here's roughly what you're trying to connect. Let me go ahead and fill in the blanks and make the rest for you. If there's something that's not there, then it will let you use the CloudFormation objects. So if you scroll down here, there's the CFN resources, and these are the building blocks that you'll want. So in case you want to build it up from scratch yourself with all the CloudFormation bits, you could do it this way as well. But they call them high-level constructs, are created so that you can do this deployment without needing to know everything in between, but you can still customize the heck out of it. So this stuff's pretty cool. They're pretty close to releasing version 2. This is version 1.108, and I think I was when I started working on this earlier in the week, it was 1.106, and now it's 1.108. So it's constantly updated. But it's a useful one to look at there. Okay, let me get to it. So we got 4 minutes, and I can get to the wrap up and the takeaways real quick. So easy parts. AWS Lambda and C# is really good. There's a lot of library support from AWS. I have a link to this at the end of the presentation, and it's all going to be in my GitHub repository already. So this PowerPoint, all the code and all the bits, none of the secrets are in there. I don't have full instructions on how to set up yourself, but if you're interested in setting up yourself, reach out to me and I'll fill in the blanks and improve the documentation a bit more. But the NuGet library support for Amazon is spectacular. There's a ton of stuff, and they've got all their systems and services are all hooked up to .NET, and the ASP.NET Core hosting. There's a whole like Lambda.NET support libraries as well. So there's a ton of stuff. It's great. And the libraries are pretty small. So if you just include the pieces you need, you don't have to include the entire world. For ASP.NET Core and Lambda, I liked it because the out-of-the-box template's there. And so if you go to Visual Studio, you install the AWS toolkit, there is a file, new project, ASP.NET Core serverless image .NET 5 template that will do the baseline of what I've set up. Will get set up in there. And you can deploy the same code to ECS as a container, to Fargate, to container service, to Docker, to whatever. The same code will run. So it's great to have one code base that does it all. Auth0 I still like better than Cognito. AWS has a service called Cognito. It's not great. Auth0 I thought does almost everything right. I haven't run into something weird there, which I didn't like, but the Freetier has 2 social logins. So if you want 2, you can bring your own API key. And you can create multiple tenants. You can play with it for free, and you can use it as much as you need to, as long as you don't overrun your welcome there. CDK TypeScript is good, but TypeScript is also bad. The IDE support way better than Terraform in terms of code completion, because it's just TypeScript. So you import the library, use it, and it will fill in the blanks for you. It's like, okay, what properties I need? These are the properties I need. What are the types? Here's the types. CloudFormation is okay, but it's fully supported by Amazon, which makes it easy to work with. The static website hosting component I talked a bit about. Again, you don't need to, the template's there, which is the great thing about CDK is if people have already built these templates, you can go ahead and use them. Be careful about the sources of that, because what you're doing is you're taking someone else's open source repository and you're saying, I'm going to go ahead and deploy this into the cloud. So you may want to review the code before you accept it, because you are going to take someone else's code and put it into your cloud environment way in there. So make good choices. This one was a previous, skip over that for now. Hard parts. CDK. The packages are pretty brittle. Like if I look at my package JSON, there's like maybe 6, 7, 8 different libraries that I've included to put to do all the resources for CDK, but they have to match versions and they have to be pinned to the right version. Otherwise, bad things happen and you don't know that they happened. So version 2 has one package that does it all. And so you'll just say, I want all my resources for AWS version so-and-so. It's a lot easier than trying to figure the pieces out. There's a lot of experimental tags in the CDK, and they will break things without any notice whatsoever. Like semantic versioning doesn't exist for these experimental APIs. It's just be careful. And the TypeScript support is great. The other support's not that much. So just be mindful about that. Lambda cold starts. The performance of this could mess with you. Right now, EF Core, if you're using EF Core, there is a startup cost to EF Core. So if you have a really big database with a lot of models, you will have a long startup time while it generates these models for you. EF Core 6 is supposed to fix this. It's a lot of the performance work that's being done. So when that comes in, those models are created at compile time instead of runtime, which saves you a ton of time on startup. And we talked a bit about Lambda single requests and also latency. API gateway, the V2 is way better than the V1. I had a lot of pain and suffering with the V1, so I usually flat out recommend the V2 for what you need. So And then I ended up disabling the cores from the API gateway because it was dumb and I hated it. DynamoDB, definitely read a lot of documentation and do a lot of practice. It's definitely a lot weirder to learn than relational database, and so it takes some getting used to. That's it. My takeaways. That's my rundown of that. If there's any other questions and stuff, here's the main link. So contact information for me, the GitHub link where the code is now existing and there. And as long as this presentation is there, the code is there, all the bits are there. Like I said, if you have any questions, reach out to me. I'd love to talk about this stuff and hope to hear from you soon. If there's any other questions I can answer them now. Okay. No questions, okay. That's fine too. So yeah, please reach out if you have any questions or anything like that. Lisa, do we have to yell at anybody?
No, actually, I have the prize winners. It's Sarah, John Hawthorne, and Pablo, and they all sent me their information, so I have everyone this time.
Cool.
Yay!
Hey, nailed it. Now we just got to get the prizes from Teals from last month to get sent out.
Yeah, that'll be fun trying to get all those together.
Oh, I take them. If you cannot find the people, don't worry. I take them and keep it safe for them.
Okay, see, Pablo is being super helpful. I'm a fan of that. All right. Good. Thank you guys for listening, and I'll stop the recording.